Hi everyone, welcome to the first episode of the Power Hour, where we're going to be looking at electrical asset management. I'm Daniel Henderson. I'm a chartered electrical engineer with a varied background. So I was in Armed Forces or Royal Navy for 10 years as an electromechanical marine engineer, and then I've been in a range of different industries, so renewables, onshore and offshore wind, utilities. I've been in manufacturing, so fast-moving consumer goods, and I've been in large manufacturing in civil aerospace, so with Rolls-Royce and some broadcasting. And across all of those roles, I've been around electrical safety, so whether I've been on the end as a user, so implementing the safety rules, procedures, policies as a on behalf of the company, or whether I've been managing the electrical safety rules, procedures, and policies on behalf of either the company I work for or a client. I've always been around electrical safety, and I'm really passionate about that as a topic. Hence why we are here today. So just to start off, throughout this webinar, anyone that's on or has registered will receive the slides after the webinar via email, and you'll also get a recording sent after the webinar. On completion, we will have a post-webinar survey. Please tell us how we did, and I'll give some more information, but this is the first episode of a series. We have got some topics identified in there, but if there's anything key topics that you'd like to be considered for future topics, if you could put them in the post-webinar survey, and we can look to either see if they are included already or whether it's something that we can include for you and others that are asking for that. Please make use of the Q&A throughout. We will try and answer any questions at the end in a Q&A. And as we've said, it is a series. So if you do want to be automatically registered for future webinars, again, let us know in the chat. So this is the first episode of the Power Hour series led by myself. We have done previous webinars on arc flash ratings and principles. Obviously, that is SKANWEAR's core provision, arc flash PPE. But as we've been doing more webinars and electrical safety conferences, we're keen to expand and support the wider electrical safety principles and learn from each other's experiences. So this is a series, and we're going to start off today with it's really applicable predominantly this series to people that have duties and responsibilities to electrical safety. So whether you're a responsible person, an energy marshal, licensed electrical worker, or a duty holder, or possibly you might be a support function for those, so a health and safety manager, or you might be a general manager who needs to understand what those roles do, or you might be working towards that role. So it's just giving an understanding. Obviously, it's quite a wide topic. There's a lot of elements to managing electrical safety on electrical networks. So hence why you can't just cram it into one. So we are looking to have an ongoing series to look at the more granular points around management of electrical safety. So we're going to start off today with asset management. So just where to start off in your role as a duty holder or a responsible person. We're then going to take those principles in the second one and delve a bit further into the typical electrical maintenance on electrical equipment, more prescriptive maintenance, so the benefits of moving away from reactive into prescriptive, but then looking at the details between those time frequencies and the documentation that we use for that. We're then going to look a bit further the next month into understanding transformer oil sample analysis. So we're going to have a collaborative session with a laboratory to understand the outputs from oil samples, the limitations on those, and the potential outcomes of those from an electrical safety perspective, and possible repair options in line with those. We're going to go a little bit further into power quality on the next session. We're going to look at what that looks like, the impact that can have on a transformer, depending on types of load. So whether it's linear load, non-linear load, and what those different impacts look like, and how they can lead to an issue on your network or from a safety or reliability perspective. And then we're going to finish off the year in December and bring it back to electrical safe systems of work. And we're going to look at safety rules, risk assessments and procedures, and the importance of audit. We will be going into 2026 and continuing on with other topics, but this is just an overview of what we're going to be covering for the rest of 2025. Okay, so the learning objectives of today, we're going to be looking at where to begin as an electrical duty holder. So hopefully we're going to gain some clarity on the initial steps and key considerations to take when you take on the role. Understand the basics of an electrical asset list. So we're going to learn what important information to include on there, how it can benefit us, and its importance to manage an electrical system safely. We're also going to look at what your responsibilities are when you manage an electrical assets. So what your responsibilities are when you have electrical roles and responsibilities, including the extent of the assets or the real estate that you have under your control. Okay, so we're just going to start off and look top level at roles and responsibilities. So depending on what sector this is, again, there's going to be some common legislation. So, we've got some, it could be whether you're heavy industry or data centers or renewables or any other industry outside of there, typically, or even geographical locations. So there's going to be a range of legislation from a safety perspective overall, which impacts and defines what duties and responsibilities are in place. So without being too prescriptive about those, whether it's OSHA or the Health and Safety at Work Act or European directive, there's common terminology across them all. So typically the person with the most responsibility. So in our example today, we're going to be looking at a individual site, so a manufacturing site, for example, but it could be a building, it could be a site, it could be a region, or it could be a global approach. What we're going to take is we're just going to take this as an example, and then you guys can reflect on it in your workplace, scale it up, scale it down for what you need. So in this example, where we're looking at a site, the typical legislation is common across them all. So typically the person with the most responsibility will have duties imposed on them in the workplace for safety. So normally the person with the most responsibility is responsible for the health, safety and welfare of all employees on that site. It normally includes contractors and typically involves the public, depending on what that work arena looks like. So that person with the most responsibility is typically has that as a responsibility. Obviously, they're busy people. So in this case, it's a general manager. They're normally responsible for the whole operation, everything under there, as well as this from a safety perspective. So normally in their role, they might have that as have a technical background, but typically they're normally operational or financial. Obviously, because that's core to running the business. So where we've got high risk, high consequence systems like pressure systems, or in our example, electrical systems, they might not have that knowledge and experience in order to manage those risks that derive from those systems. So typically, that person will then provide some responsibilities or assign some responsibilities to an individual to manage those high risk, high consequence systems on their behalf. So in our example, we are nominating Eddie Electrical here as our electrical responsible person, but that could be a energy marshal or licensed electrical worker, whatever definitions are used in your geographical location. So typically, they'll be given a set of responsibilities. Best practice is typically to define those in writing. So what their responsibilities are, what their boundaries are, where they go from and to. So it might be from the initial connection site with the utility provider. There might be multiple stakeholders or owners on a site. So you might have some cross-boundary works to take into consideration. So they should be defined in writing. Any responsibilities also defined in there of what they are responsible for managing, and any organizational. It's good to include a escalation route or a line management path, because it can be quite lonely being an electrical responsible person or duty holder. You've got the responsibility, and sometimes you need support in either decision making, resources, budget, and it's good to define that escalation path or that support path, because often, as long as the lights are on, it gets forgot about. So it's good to define that in the responsibility definition document that you have in place for appointing your persons. Another person that I'm just going to bring into this format is you might appoint a health and safety manager to manage general health and safety functions on the site or in the workplace. So that may cover all the other general health and safety items in that location. And it's just good to have that. So in this example where we are nominating Harry HSE in that function, sometimes the responsible person for electrical systems comes into the health and safety department, but more often than not, they're a technical function. So they are often looking after other things. I'm just mentioning this in this instance because from a communication perspective, there are a lot of synergies between the two roles. So I'm just keen to, understand that there are these two roles. They do support each other. So it's good practice to have those interactions, understand where you have got those synergies, and try and keep those communication routes going so that if there are times when you need to lean or support on each other or challenge each other, um, it's done in the most productive way possible. We don't want any obstacles. An example of a obstacle that you might come along that I've experienced in the past is where the health and safety manager has been responsible for PPE across the business. So if the electrical responsible person wants to run, for example, a electrical or arc flash PPE program, it may need to be approved by the health and safety manager. And this, so if they don't understand what you're doing, what your priorities are, and how you're working on those, that can cause delay and it can cause issues in the approval process. So it's really good to support each other because we do have work streams that overlap across our day-to-day work activities. So that's typically how we do have those responsibilities defined. Obviously, the general manager is still accountable, still responsible for the health, safety, and welfare of everyone in that workplace. They can then delegate responsibility, but they can't delegate accountability, and that'll be common in whatever geographical location you are in. So just whilst we're here, are we okay just to do a quick poll, Ben? So does your company have a process for nominating a responsible electrical person in writing? Yes, that's really good. I've got to, didn't expect anything less, but it seems that the majority of people that are on here do have a process for nominating people. For the people that don't, it might be that you're not sure because it might not be your core function. But again, if it's something that you want to talk about outside of this session, yeah, please get in touch and we can see what that may look like and if we can support with that or point you in the right direction.
Yeah.
Right, so we're going to continue the roles and responsibilities part and go into some duties. Again, it's quite a wide subject of managing electrical systems and safe systems of work. So we'll kind of briefly cover those, but also down the line on other sessions within the series, we are going to look into them in more depth around good examples, bad examples in the middle, that sort of stuff. So if you are in this role, one of the things that you might start looking at initially, so as you first get into the position, is staffing. So what does that look like in your situation? Do people that work on and around electrical systems, do they work for yourself? Do they work for yourself and other departments or other departments? What's the use of contractors? So do you rely heavily on contractors? You might predominantly use contractors and not very much of your own employees, depending on what your function is in those, whatever your situation is, what your geographical location looks like. So are they widespread? Are they in one place? And then from a competency perspective, you've got to look at the skills, the knowledge, the aptitude, the training, and the experience of those individuals to make sure that they're competent. Is there a process for doing that? Is there an authorization process for you to assess or someone to assess their competence and define them, and then obviously put their nomination of competence into writing to give them limitations? Do we have safe systems of work in place when we're looking at those? So if it's a new facility or if it's an established facility, do we have safety rules in place? Do we have an electrical policy and procedures? Do we have risk assessments, training requirements and training matrices for competencies? If we do, are they fit for purpose? If it's a new facility, so if it's just been built and you've come in, hopefully you're involved in the build process, but often from experience, the person that's responsible for the electrical systems might be hired later on in the build process. So you might come in after this has already been established. So if you have, do you need to establish safety rules, or does the company have some? Do you need to establish a policy and procedures yourself and risk assessments? Obviously, that's a big mammoth task to do and front load that at the start of a new role. Again, an overlooked thing, but massively important, equipment. So this could be things like working locks, safety locks, key safes and lock boxes, rescue hooks, insulated matting, basic things that are often overlooked in a new facility or an established facility for that matter. Do you have the right test equipment? Do you have a process for calibrating your test equipment? These are all things that we're going to be considering in our role. Documentation is a massive one. So do we have the right drawings, schedules, cable schedules, operations and maintenance manuals, operating procedures? So if it's a brand new facility, have they come across from the design drawings to as built? If it's an established facility, have they been are they up to date? Have they been updated as we've enhanced, upgraded the network along the way? What's the asset use? So what type of loads on the end of the electrical network? What's the life of the asset and the expectations? What environments is it in? Is it in a harsh environment? Is it wet? Is it cold? Is it inside, outside, chemical? There's a lot of considerations which we're going to look at further down the line for our maintenance perspective, and obviously the asset life. Is there a maintenance history and a maintenance program? If it's established, is it fit for purpose? If it's a new facility, you might need to establish that yourself, which again is a mammoth task to front load that. With that, what system do you use? You might use a computerized maintenance management system. You might use just a very basic method, but it's obviously key to the safe operation and reliability of those assets. You might have budget responsibilities. Typically, we do. So, do we have responsibilities for managing a budget for maintenance? Might be for survey work. Might be for some training or project work. Is that budget suitable and sufficient? If you've got an older network, often the maintenance costs go up because they need to be maintained more. So, all of that is something to consider in our roles, and something that we've got to think about, just to add a bit of complexity to what we do. We're typically involved in capital investment programs. So it might be that we're involved because it's upgrade and enhancement or replacement of network infrastructure, but often we're indirectly involved with things like what's going on the end of our network. So whether it's a addition or enhancement to a data center or a production line or an extension to an office building, all of this has got to be considered from our side because we manage the network. We need to know what that load looks like to make sure it's safe, but also that it's still reliable as well and it fits the business needs. So we're often involved in those. Sometimes we're not, which can cause issues where, especially with load management. Um, in the capital investment process, do we have do we not have a depreciation of asset process for the value and the life? So what the life expectation is of the asset, and that should depreciate the cost over time, so we can predict and forecast when we're going to look to change those assets out, or at least review them. Are there any future expansions or reductions in place? So whether that's going to either push the load up where we need to manage that, or even when you're going to reduce the load, it has an impact on the network, especially when we've got low loads on assets, or if we've got issues with tap changes, things there. So we've got a lot to consider, hence the guy spinning all the plates. We're not going to cover all those today, so we're going to look at a good starting point. So we've got the procedural stuff that we're going to look at down the line because that's quite a wide subject. We're going to look today at asset management from an electrical perspective. So just to give a bit of an overview, obviously there's lots of different resources out there for asset management. So you've got the Institute of Asset Management, we've got the Global Forum of Maintenance and Asset Maintenance requirements. So there's lots of resources, and your own businesses probably have processes around asset management and asset management principles. But just as a top level, any business has typically got a business strategy. So they'll where we are now as a business, what we want to achieve in a certain time scale. So whether it's a 5-year plan or a 10-year plan, typically it's going to be a strategy on where they want to get to in whatever industry they're in. So then where this comes into it, we'll have the asset policy, which will break down the assets into groups and set aims into how they interact with the strategy. And then from a strategic level, there'll be asset management strategies then, which then go deeper into those groups to define what those aims are. So there'll be aims then that then link to how those assets help achieve that overall business strategy. So it might be that the business strategy is we've gone as far as we've gone, that's where we want to be, and the business strategy might be to maintain where they are, or it might be that there's projected growth, which might need the electrical assets either to continue to operate for a period of time. It might be outside of the asset life, or it might be that they've got to then enhance and replace the infrastructure to then meet those future operational predictions. So that strategic level then comes down into a tactical level, which is where typically the asset management plans are put into place. So those asset management plans, they can be multiple. It can be done by groups or by a core subject. So we're going to focus on an electrical asset management plan. And typically we've got like asset information, location. We'll normally have a condition assessment. So how the asset's looking and how it's operating, the agent performance, any replacement strategies, and we'll also have any benchmarks. So how we then want that to function throughout this time period. And then we'll come down from that into the operational conditions, which is where the majority of our roles are going to sit. And that's where the maintenance plans come into it, as well as any future expansion work. So in the maintenance strategy, this is going to set out how we get those assets to perform as expected and meet the lifespan that we've projected in line with meeting that business strategy. So within that, there are potential limitations and opportunities as a duty holder. So some limitations might be where the business strategy is we're staying where we are. There's no opportunity or appetite for growth. So it might be that we have to get the most out of our assets and focus mainly on the maintenance element. And there might be opportunities where we do need to change and upgrade a lot of our network infrastructure, in which case, it's investment and we can try and get the best possible outcomes that we can from an infrastructure perspective, which will help us as duty holders and help the end user from a safety, operation and maintainability perspective. And obviously we all love shiny things, so it's good if we do get that opportunity along the way. So just to kind of break that down a bit further, it'll give us the plan will give us the purpose and the context, so what we're trying to do, how we're trying to do it. We'll define key responsibilities, which obviously drives the success in the asset management process. We'll put governance there and the frequencies of those reviews, because we'll need that, because often business strategies and directions will change over time depending on what market you're in. Sometimes then this plan will need to be reflective of that. It'll define the key organization and people responsible. So in that process, we might be responsible for the electrical side, but there may then be inputs from controlling and finance from a financial perspective, operations over the delivery side. It might go into market and sales, depending on what function you're in. So there are key people that will be involved in this process. Obviously, there will be some key decision making. A key element to where we're going to look is the risk management aspect, both from a safety perspective and from a business risk perspective, which we're going to look at today. So the key bit where we're going to be talking about is this life cycle process. So where we acquire or create the asset, where we then operate the asset and maintain it throughout its life cycle. And then on completion, when it gets towards the end of its life cycle, either review it and keep it going or dispose of the asset. So we're going to start now right at the beginning with an asset list. So it sounds really basic to say that we need to get a suitable and sufficient asset list in place. But I've been to multiple blue chip organizations, and the amount of times I've seen insufficient information in asset lists. So whether it's in a very basic spreadsheet or whether it's in a asset management program that can help you define life and condition assessments, or whether it's somewhere in the middle, just in your computerized maintenance management system, the outputs are only as good as what goes in. And it can either help or hinder you down the line, both from a maintenance perspective, a safety perspective, reliability side, or even future planning. So getting this information right the first time is really key. So the example that we're looking at now, We just got a single line diagram for this production site that we're using as an example with a range of different assets, high voltage, low voltage. So we're just going to look at what we would typically have on an asset list and why, and some of how that can benefit us as we go along. So when we're looking at switchgear, typically what the item is, so whether it's a switch, a circuit breaker, a transformer, batteries, whatever it is, the apparatus ID. So it's good to have this written with exactly what's on the asset. So whether it's number one powerhouse transformer as an example, it's good to have that exactly what's written on the asset, which should be reflective on your single line or your one line diagram, because again, it can help us if we're preparing things like switching programs as an example to make sure they're as accurate as they can possibly be. The location, so this might be, try and be specific. So it might be number one HV switch room, and maybe try and include some information like if it's indoor, if it's outdoor. So further on, we can start making decisions based on what environment that's in. The manufacturer and model, so who made the asset and the model of the asset, the rating of the asset. So if it's switchgear, it'll be in amps. If it's a transformer, it'll be in kVA or MVA. The serial number. So typically every panel or every key component will have a unique serial number. Again, from a traceability perspective, which what we'll come to later on, it's important. A switchgear, what's the insulation medium? So is it gas insulated switchgear? Is it oil? Is it vacuum? Is it air? So this, again, that's good to know, and it can be important both from a risk perspective, or you might even have in some geographical locations, if it's gas insulated switchgear, it might be a greenhouse gas, and over a certain quantity in weight, you might need to record that from a legislation perspective for greenhouse gases. If it's, I like to include the cable box. So typically newer installations are going to be air boxes. So it's just going to just bolted on cover. Some older installations were pitch or compound bitumen filled boxes. Again, this will impact your maintenance or have an impact on your maintenance of what you can do and what you can't do. But it's also good information down the line. So if you do have to do an asset replacement, one of the considerations will be how do you remove the pitch compound? It's quite a messy process, heat required. Or if you're replacing the whole box, is there an obsolescence requirement for getting a replacement box? So it's good information to have. Anything that's going to help us is people that manage electrical networks, anything that's going to help, include it in your asset list. Does it have a voltage transformer fitted? If it does, what's the insulation medium? What's the serial number? Again, we need to know where VTs are from a risk perspective as well. Relays. So again, it's quite a small box on here, but you might need a comprehensive list of what protection relays are fitted in there, and probably a separate document that has what relays are fitted, what settings they have. That's all quite important from a maintenance perspective. And then year of manufacture is also good to include in there. Again, if you're going to start looking at age, which we'll look at further down the line. And if we're looking at transformers, a lot of the information is going to be the same. It's good to include the primary voltage and the secondary voltage. What the winding configuration is on the transformer. The tap changer. So does it have a tap changer, an on-load tap changer as an example? If it has an on-load tap changer, make, manufacturer, model, whether it's, again, any key considerations with that. If it's an offload tap changer, is it lockable? Is it locked to prevent operation on load? Does it have necessary signage on there? So again, all safety related information that's good to keep in one place. The tap setting. So again, it's probably something that you'll seldom use, having the actual tap setting on a offload tap changer recorded, but there might be instances where if you have to parallel transformers or have one transformer feeding a common board during a maintenance or an outage, for example, or if you have voltage management issues, i.e. over voltage or under voltage on the end application, again, it's a good reference, especially when you've got a wide geographical spread. which might need travel and things like that to go and actually do an assessment at the what volt. It can give a good indication of what the typical voltage is going to look like just by reviewing your asset list. Again, manufacturer, the capacity in kVA, year of manufacturer, impedance, again, is important, especially when we're matching. It links into the fault levels, but also if we're paralleling transformers, we need those to be, similarly matched from that perspective. What cooling, so whether it's an oil-filled or fluid-filled transformer, whether it's a cast resin transformer, fan-cooled, fan-assisted cooling, all of that's important because it'll impact what the maintenance looks like, the environment it's in, and obviously, I suppose, how we then tailor those maintenance requirements around there. Whether it has a conservator on it or not, so if we've got some transformers have a tank elevated above them, known as the conservator. And if it does, it's likely to have then a Buchholz relay in there from a protection side. So it's again, it's information that will help us from a maintenance perspective and a planning perspective in there, especially knowing what assets and what we have to do in our maintenance. If it's is the asset hermetically sealed? Is it free breathing? Does it have a breather fitted? Also good information. So again, where we know what we need to do, what approach we need to take from an oil sample perspective. Does it have a sample point on the amount of transformers, not just old ones, but new ones where if it's not specified, the transformer will come without a sample cock fitted, which again hinders us from a maintenance perspective because you can gain so much information from oil analysis on your assets. Oil quantity, again, you probably hardly ever use it, but if ever you do need to plan in, dropping the oil, whether it's for an inspection or whether there's an issue where you need to change the oil, again, it's a good bit of information to have that might save you traveling if it's a long way to get to the location. And then again, just the box information. So whether it's air boxes or whether the compound filled. So again, anything that might help you as a responsible person or a duty holder, it's all good information and it's up to you how you have that. There's other things to add on, which we're going to look at soon, but as core information, this can help us so much, not just from a maintenance side, but from a outage planning, from a enhancement and upgrade process. We can use this asset list for so many different outcomes. So we're just going to continue this on a little bit further. So I've kind of populated the start of an asset list with switchgear. So we've got the information there. And one of the first places where I would start if I was looking at my electrical network was whether we've got any safety related defects on any of the equipment on that network. So if it's a new facility, a good reference for this can be reaching out to the manufacturer to see if there's been any product issues or product recalls. It also might, if it's a new facility, it might be good to do that because in a construction side, from experience with the procurement and the installation done by the general contractor that's doing the actual build process, often the warranty and any downstream information will go to those. So it's good practice if it hasn't been handed over just to get in touch with the manufacturer anyway. First of all, let's see if the warranty is with yourselves as the owner, as the client. But then secondly, if there's any information throughout that life cycle of the asset from the manufacturer, that they can then provide that any recalls or safety related information to you as the owner. It'll likely just go to the procurement of the construction company. If again, if the manufacturer is still going, probably on newer sites. In my example here, that this is no longer supported. So again, it's you're gonna be very limited information. There are other resources out there, but in the UK and EU, we have the Energy Networks Association as a resource where we can use NEDAs or National Equipment Defect Reporting Scheme, where we can look for any information that are reported, whether it's a defect or a dangerous incident notification, or whether it's a suspension of operation practice. So any safety related defects will typically be, there's been an issue on our equipment. This is what the issue was. this is the circumstances how it occurred, and then there's typically a outcome. So it might be do not operate this equipment live unless it meets these. There might be considerations in there. It might be period, you do not operate this equipment. And then depending on the situation within that operational restriction, it might be under investigation by the manufacturer or by a subject matter expert. Sometimes when you do have an operational restriction, it might be there might be an outcome and an update. So it might be a case that the manufacturer has investigated this particular operational restriction, and the outcomes are it's only affected a batch. So it can be tracked down potentially to batch numbers, batch items to say only 25 or hundreds. It can be limited to what's affected by it, which then allows the restriction to be lifted on everyone else's equipment. It could be age related, so it might say anything manufactured before this point, not to be operated, anything outside of there. So there's always guidance and direction provided, which is good, and that can come either from the manufacturer or from the investigating body within the ENA process. So as I'm looking now, I know my equipment's not supported, so I can't go to the manufacturer in my example. So I've looked in NEDAs for any operational restrictions, and I've identified that this one particular bit of switchgear is subject to a suspension of operation practice. So this one in particular is linked to partial discharge. So I'm starting to think, I'd start to be thinking about, firstly, how does this impact the people that work on and near that equipment? And then secondly, how does this impact business continuity, which we'll look at. So just whilst we're on the subject and just to break me talking for a while, we'll have a quick poll. So do any of you know if your assets have an operational restriction on? So either yes, and you're aware, no, there's none, or you might not be sure. That is good mix, yeah. Again, it might depend on your geographical location. Like we know we've got a good resource for UK and some Europe. Depending where you are, you might not have similar things. And if your assets are older and they're not supported anymore, again, that might be where you sit currently, or it might be that you're not directly responsible for assets, so you might not know. But again, it's if we want to have a follow up afterwards, reach out and we can either try and support you or point you in the right direction, depending on where you're based. This time, yes, right. So yeah, so just continuing on now. So initially we've looked at safety because that's the most important, that's paramount. Next, with my asset list, I'd start by looking at conducting a business impact assessment. So different businesses probably have your own processes for doing your business impact assessment around risk management and loss prevention. So you'll have a safety side, but then this is more around business continuity. So what that looks like for your business, what the recovery plan looks like, downtime looks like. So from an electrical perspective with my asset list, I would typically be, if I didn't understand the network or what the end user was doing, this is typically a collaborative piece of work that you might do with operations or engineering staff, depending on that function. And it's just top level here, but we'd be looking at what areas are supplied. So what does that equipment supply? If it did go down, what would the impacts look like from a production side, but also are there this particular outcomes where you might have an outage which can then lead to a safety related incident or an environmental incident? So as an example, in my experience in one production facility where I was the responsible person for the network, in the event of a power outage, a lot of that production was heavy steam use. So you had steam going into rotating pressure vessels and drums. In the event of power outage, that motor that drove that rotating pressure vessel couldn't rotate anymore. So in a period of time, the steam cut off anyway, but the steam could cool down, and then that cold condensate then could then cause that pressure vessel to rupture, which would lead to a safety related incident, especially for anyone in that vicinity. It would go with some impact. So obviously that was a direct safety related impact that came from loss of supplies in that event. So that from that assessment, that could then be, what is the procedure in the event of that? You need a process then to take away that safety element. Another example is in a water treatment facility, one of which I was involved with it had a biological process in the final stage before the water was then discharged into a water course, so into a river. Typically in a biological process, the bacteria is normally aerated. So typically you'll have air blowers blowing air into the water or the process to then keep that biological process aerated. In the event of a power outage in that region, you're then going to lose that aeration process. And then you've got a time when that bacteria then starts to deplete, which can then lead to an environmental incident where you are putting untreated water into a water course. So again, these are all considerations that need to come out as part of this business impact assessment. And then outside of the safety and the environmental considerations, we now need to look at the business side as well from a single point of failure perspective or business impact. So as I'm looking here at my small network, we've got some boards. So this one that's denoted as L1 and L2 substation, where I've got two transformers feeding a common LV board. Both of those transformers, one's fed off one side of a 11 kV board and the other one's fed off the other. So when this has been designed on both of those, they've been in the design stage. They've been identified as critical assets. So they've been identified and singled out as critical assets. And that's why in the planning, they've been built with N+1 capability. So in the event of losing circuit breaker, cable, transformer, even the full side of the board, or taking those off from a maintenance perspective, you've got that N+1 redundancy built in there so that you can keep those assets going, or in the event of a fault, hopefully recover those assets by buzz coupling and getting that in back recovered in a short period of time as part of your recovery plan. As part of that, other considerations I've got two assets here which are feeding single points of failure. But I know that in the event of failure there, the location of those LV switchboards are close to a roadway on site that's accessible. There's doors that can access, and I've got generator connection points at a very accessible level. So from that recovery plan, I know we can get a generator in there within 4 hours and the business impact will be minimal. I've got a single point of failure where it's located in a basement area, which would be very difficult to get any generation to in the event of a failure, which would lead to a business impact. So that would be high up on my priority list. And then I've got a single point of failure, which is located, which is for a single common utility, which is water for the process. I know that's important, and it's key to all of the manufacturing processes. So again, that'll be high up on my priority list to get some to get some potential recovery options in there, whether it's a permanent generator, whether it's a route for a connected generator, or an alternative supply. These will be part of my assessment to identify these and get them across the radar from a loss prevention and risk management element to the business to say these are the risks, and then gain that appetite from the company to try and resolve those issues. Just taking this a little bit further into transformers, same process. So I'd still be doing my single points of failure, looking at those recovery plans, but then other items I'd start looking at would be things like long lead time items. So if I'm looking at, well, we all know how long it takes to procure a bit of electrical equipment. You're talking like 12 to 20 weeks, depending what it is, sometimes longer if it's more unique, which is why some of the things I'd be looking at typically here would be primary and secondary voltage. So, and the size or the capacity of the transformer. So typically you might get off the shelf transformers if it's a standard capacity. So maybe 800 kVA or 1 MVA. If it's that it got a common primary and common secondary for your area. So 11 kV to 400 or 415 in the UK where this asset list was generated. I know that if I did have a loss, I could probably get one of those fairly quick. Some of the things that would stand out to me would be these two transformers as an example, where the secondary voltage is 3.3 kV and it's quite a large, so it's 4 MVA transformers. So they're not going to be sat on the shelf somewhere. So this might be where you start looking at other options. I know on further analysis, these both feed into a common board, but that can be buzz coupled. So again, although these are high risk at the moment because they will be hard to get hold of, I'd probably move them to medium risk because it's got N+1 capability. Whereas these assets here are single points of failure. It's got a strange secondary size, so 750 volts, and it's quite a large transformer with 3.15 MVA. So I know that both of these would be my high risk items from a long lead time item. Each business might have different rules around strategic spares. Sometimes it's got to be costed over like $100,000 as an example, or 100,000 euros to be classed as a strategic spare, which a transformer of this size probably wouldn't. But you've got to then take that into account with what that business downtime would look like, and business impact, business cost, to try and look where this fits from a strategic spares perspective. And then finally, I'd be looking at if we've got any obsolescence. So if it's older equipment, is any of it obsolete? What does it look like for getting spares? So in the event of a failure of an individual component, could that impact my business reliability or safety perspective from that perspective, and see how that impacts the business. And then finally, if you're looking at a replacement process, or if you're looking to start putting some proposals together, it might be that you start looking at an age-based asset replacement. So again, if you've got year manufacturers for switchgear or for transformers, again, you can try and group these and go, right, these are all my older assets. Try and see if there's any safety considerations, and then make a decision based on there. And it might be that, in 5 years, you're going to replace these, 10 years, you're going to replace them, until you start establishing that life cycle asset replacement process, which might not be existent in your business. Often with electrical infrastructure, it gets forgot about. As long as the lights are on, everybody's happy. And typically these things aren't considered unless either A, you're proactive, or B, there's a failure, which is the most likely. So typically we'll get 25 years out of an asset. Now I know we've got a lot older assets on our networks. I suppose the interesting bit is whether the newer equipment that's on our networks now is built to the same standard as the older equipment, and whether it lasts the test of time as the older equipment has. So that'll be interesting as we progress. And just one more thing whilst we're on before we kind of finish is this is looking at an individual site from a downtime or a support perspective. If you're looking at either a site or a wider region, you might identify where you've got key bits of equipment that's interchangeable. So you might have one of these odd size transformers, but you might have another one in a different part of your business that's less market critical to your machine or your process. So it might be a case of, yes, I haven't got a spare, but in the event of an outage on my key market critical asset, within 2 days, I could take that asset from there, transport it to here, get it in the system, get it commissioned, and then get energized and get that process up and running again. So having this top level holistic view, it adds so much value to, especially looking from a safety side, but definitely business continuity. By having that wide view, it lets you take so many different approaches to make sure that your network is you have lots of redundancy built in there. So just whilst we're here to finish up, do you have a well-maintained, up-to-date electrical asset management list? A lot better than I thought, actually. It's so yeah, well done everyone that has got an up-to-date asset list. For those that haven't, and again, it might not be your area, or it might be that you've got, you're in a transition period. But if you want to, even just a second opinion, or if you wanted to have a discussion outside of here, feel free to get in touch, and we can either support you or try and point you in the right direction. Try and add some of our experience to help those that need it. Yeah, so just to summarize, I know it's a lot just to talk about one subject, but once we have got those things in place, there's a lot of positive key outputs that come from having these in place. So first of all, and more importantly, any safety related defects are known and we can do something about them, whether it's replacing or putting a process in place or engineering it out. At least when we know about it, we can actually do something about it. We can define our maintenance strategies and programs based on the equipment, the environment, age, and O&M guidance. So the environment that it's in can obviously have an impact on what those frequencies look like, which we're going to look at in the next session. Asset lifecycle strategies can be defined, so you can identify where they are in their lifecycle strategy and what the business direction is and where it fits. So you can start deciding how those assets can be used and what expected life you will get out of those. And yet there's obviously lots of positive steps, but the next thing that we're going to look at in our journey is going to cover like typical prescriptive maintenance on electrical assets. So this is going to be using resources like manuals and local guidance like NFPA 70B as an example. But then we're going to take into account the stuff between those frequencies, so things like the environmental impact, the end use, the load, and how those frequencies are impacted, and just key things to then sort of measures that you might put in between those. Yeah, so just before we finish, if anyone does want to have a session outside of here, even as a second pair of eyes, or to look at what you have from either an asset list perspective, asset direction, or we do have access to Netters. So if you just wanted to see if any of your assets might be have any operational restrictions on there, if you wanted to have a discussion about operational restrictions, yeah, please let us know and we can try and support you with that. We do have an up and coming conference for electrical safety and operational reliability on the 15th and 16th of October in Chantilly, Virginia. So if you're in North America and it's of interest, please get in touch if you'd like to attend. And finally, obviously, we are doing this as a series. One of the other things that we're looking at doing is perhaps getting people with like suitable knowledge and experience from different backgrounds to see if we can get a workshop either online or in person, just to talk about some key topics to try and learn from each other and try and identify any gaps where we can try and put some steps in place and learn from each other's best experiences. So it might be things like competence or electrical safety programs or key parts of that, or safety rules or procedures, just to try and focus on a key topic, often where competence is a big one, where we know there's gaps, but it'll be different by different industry. But I think we do have a lot at the conferences. We have a lot of engagement. We have a lot of positive discussion, and often then it's because you're in that space, that environment of when it happens. Outside of that, it goes a bit cold, obviously, because we're away from it. So I think the intention is to try and keep those conversations going, because there's so much good conversation and positive engagement that happens, and challenge at the conferences. And it's good to try and help us make our work environment safer and see where we have got synergies to support each other.
Good stuff. Should we jump into the Q&A, Dan?
Yeah, that's me. Thanks very much. We'll try and get some questions in if we can.
Good stuff. So the first one then, so is the duty holder a person or the organization? Can the electrical duty holder be someone who has no electrical background?
So the overall responsibility for the health, safety, and welfare of the people obviously sits typically with the most responsible person. So the person at the top. Again, so if there is an incident, it's happened, doesn't it? So we've already had the incident, but typically that person is still responsible for the safety of people. They may not be subject matter experts, so it's best practice then to nominate someone to be responsible as the duty holder to manage the electrical safety elements on behalf of the company. So typically they are embedded within the company. So it might be the electrical engineer from a site perspective, or a regional electrical engineer, or someone that typically knows the business. They know the safe systems of work, and they know how those interact with the people on the end of it. Sometimes you can use a third party. So sometimes people nominate a third party contractor to do it on their behalf. But again, the overall responsibility still sits with the owner. You're still accountable then for the health, safety, and welfare of the people. So you've still got to apply due diligence. You can't just hand it over to someone and just that's your get out of jail card.
Thank you, Dan. So the next one. So does the NEDA system provide details on LV equipment?
Yeah, it covers any network equipment that's well obviously reported. If it hasn't been reported, it's not known. So if it's typically it's anyone that's a member will raise the incident. So it's a paid service done through the Energy Networks Association. Anyone that's a member can then raise a defect, a dangerous incident notification, or a suspension of operational practice. So if it's not reported, it can't get circulated to others. So as soon as something happens, it gets processed and then it gets sent out to everybody that's a member. So if it is a failure, it will be covered. Often these things aren't reported. So people at site are dealing with the immediate firefighting on the not literally, I hope not firefighting, but they're trying to get everything operational again. So often until that RCA takes place and then they step back, often these things aren't reported. So it's only when equipment failures are reported that then the wider community gets to know about it.
Thank you, Dan. So the next one, what would the risk assessment look like for switching operations on LV switchgear that is no longer supported?
Good question. I think a lot of that would be down to what the equipment, there's a lot of different factors around that equipment, but we've got old LV switchgear that is, it's still safe to operate, it's still well maintained, but the considerations that you would take in that would be things like the fault levels. So have you got a fault levels survey? Is it maintained? So you'd need to know what the fault level looks like, what the operating method looks like. So if you've got a, a suitable fault level that's within risk tolerance, and it might be that it's remotely operated, great news. If it's locally operated, it's a case of is it maintained, that pre-use check, and possibly well definitely your PPE provision to make sure your PPE is suitable and sufficient for the fault rating of the board. Access and egress, if it's difficult to get to, in the event of something going wrong, you need to make sure that you've got a defined access and egress route. A company safety person might be a consideration. It might be part of your policy. So if something does go wrong, what's your emergency response process? There's lots of different considerations around that question. But yeah, age isn't just a factor to say, it's too dangerous to operate. It's everything else that you need to take into consideration.
Thank you, Dan. So, what degree of theoretical knowledge is expected of the electrical duty holder? Personally, I'm an intern student and still somewhat limited knowledge in electrical power systems. What is the industry standard for reference? I am in the UK and aspire to achieve the CENG title.
Again, interesting. So being a chartered engineer, a lot of the elements of that's going to be around your learning objectives. So yeah, so if you're, it's potentially you can come out, you can get a master's degree, which satisfies like your A competencies. You'll do project work and do your B competencies within some of that. So potentially you could come out of university and within a short period of time get achieve your chartered status as a chartered engineer. But from an electrical safety perspective, a big element of that is experience. So yeah, you could be a chartered engineer, but you might not necessarily have the experience to then be responsible for electrical safety in the workplace. In reality, you need that exposure. So when we talk about the skill, knowledge, aptitude, training, and experience of the individual, it's around having the exposure around electrical safe systems of work, what that looks like, different environments, risk assessment, different types of equipment, and there's so many elements to that. It's not a easy thing to answer, but they do support each other. The chartered path and being responsible for electrical networks, but not to say just because you're chartered you can't go and be an electrical duty holder. You need all those other elements at the same time.
Good stuff. So, I think we've got time for one more. So, Dan, this next one is, could you touch a little more on the skate analogy that you mentioned earlier?
Yeah, so different. It's fairly common from a safety perspective, but it's I mean some people have different elements. So like the acronym kind of covers your skills, knowledge, aptitude, training, and experience. So the skills bit sometimes gets debated. So your skills is typically if you're working on and around electrical networks or operating electrical networks, such as an electrical authorized person, someone doing switching, as an example. Some people argue, I would like a lot of people would say from a skills perspective, you need to have an element of electrical training. So you need to understand the core principles of electrical systems. So it may not need to be a chartered electrical engineer or a power systems design engineer, but you should have some training around electrical systems. Some people debate that and say as long as you've got the right training, or you can be sort of given elements of that, you might negate the skills element, the electrical core background. I still think it's an important factor, but we're not on here for a debate. The knowledge is so knowledge of the system, so familiarization. So if you're going to be operating a network and working on a network, you need to know it. And that's why we do have so many issues in construction, as an example, because it's brand new. People are focusing on just individual bits. But in reality, in an operational setting, you need to have knowledge and familiarization of the layout of the network. So you know what it is, what it feeds, type of equipment, what it's like, the quirks. There's little quirks on networks where you might have two sources of supply that might not be easy to identify. So that's where that comes into it. Aptitude is what your attitude's like towards your role and safety. So you might be a really good engineer, but you might not be too serious in the workplace. You might not take your responsibility as serious as it needs to be from a safety perspective. You might be distracted. You might have things going on. So although you're great at what you do, you need to take into consideration things like the human elements that might impact the safety or the operation of the network. Then the training is training relevant to what they're doing. So that's more vocational. So whether they've done like HV training, so like how to do switching programs in a safe environment, switching, issuing of safety documents, proven dead. So using like your live dead live method, things like that. So it's your training around those, which will be based upon matrices within your company. And then the experience. So it's that experience element. So you need to demonstrate that you have got the experience to fulfill the role. So you have been shown it, you've operated it under supervision, you've done a level of switching in a safe environment. And once all those factors are considered and met to a suitable standard, then you can assess and say, yes, this person is competent. And it just gives you a good level ground to assess best how someone's competent for the role they're doing.
Think we've got time for one more, Dan. So, how can you define is it safe to operate if old asset RMU is still in operation, but the SFS gas are lower than the allowed level?
If so with a ring main unit, obviously like there's a range of different ages, but the SF6, did you say? So it's a
Yes.
sulfur hexafluoride. Yeah, so if it's SF6, if you've got typically you've got a gauge on there. If it's in the green, you've got a suitable insulating. So that's your insulation medium between those contacts. So whether it's oil, vacuum, or SF6 in this example, the purpose of that insulating medium is to quench that arc or suppress that arc when that breaker is opening. So when it's going between the closed position and the open, or whether open and the closed, there's going to be an arc generated, and that's the function of it. So when it's in that low P, if it's in the red, you do not operate that the switch gear. If it's in the red, you've got a loss of insulating medium. You've got so you've got nothing there to suppress the arc. So that arc can develop, and then you can lead to a flashover. So if it is on an older unit, doesn't matter of the age. Actually, you could have a new unit, but if the SF6 is in the red, do not operate.